Okay, guys, welcome back. So the internet died during the last video, and then my computer died. So it was just not, the world was conspiring against the video. So where we left off was to find the area of a regular n-gon, which is just like a polygon with sides n. Polygon with n sides. Okay, it's got side length S and cute little apothem A. We'll have to divide it into n congruent triangles, isosceles triangles. So what that's saying is if we look at this little hexagon down here, and we make 6 little congruent triangles. Okay, you see them? There's 6. 1, 2, 3, 4, 5, 6. Whoops. That's 7. That one's 7. That's a heptagon. Okay, we've got 7 little cute triangles. If we look at just one of those triangles, the base of that triangle is the side length S. So S is like the base. Okay, our little apothem, A, is the height. Okay, so the area for that one triangle is 1/2 the base and the height multiplied together, so the S and the A, or the A and the S. All right, now we don't just have one of those triangles. We have 1, 2, 3, 4, 5, 6, 7 of them. So that's n, that's the side number. So we have to throw an n on there. In this case, it would be 7, right? And that's where we get the formula from. The area for this regular polygon is the number of sides times the baby triangles, area of baby triangle, okay, where the apothem is the height and the S is the base. Okie dokie, here we go. Okay, I'm going to zoom in a lot in a second. So we have to find an exact and a rounded answer. We are going to round to the 100th place because that's what I've already practiced today before the internet died. Okay, so first we are going to find, we're going to start connecting the center to our vertices. So we'll make 3 congruent baby triangles inside the big triangle. I'm going to erase this 18 because I don't like where it's put. If you want, you can erase it, scratch it out too, and rewrite it. I'm going to rewrite that 18 right there. That's where the 18 belongs. All right, I'm going to draw in my apothem. Which I don't know. And I also don't know the side length for the big triangle. But I know that it's 2 times whatever this is right here. Now, on this little baby triangle right there, I only know one side and one angle, which isn't enough to help me out. So I'm going to remember what we said about the sum of the central angles. So if I rotate around this entire center, I will have to spin 360 degrees. So if I chop that 360 degrees evenly between 1, 2, 3 central angles, I just have to divide 360 by 3. So we do 360 degrees divided by the 3 central angles gives us 120 degrees for each central angle. Okay, now the apothem is a bisector of the central angle. So these two little babies' angles are congruent, and they're both 60 because they're half of 120. So I'm going to call this one 60. And now I'm going to have a 30, 60, 90 right triangle where this one is 30 degrees. Okay. So now we have a 30, 60, 90 triangle. Let me draw it off to the side. Where I have a hypotenuse of 18. This is my 60. This is my 30. Okay, so to go from the hypotenuse to the little baby short side, I have to divide by 2. So that short side is 9. And that is my apothem. Okay, to go from the short side to the long leg, I have to multiply by root 3. So that is 9 root 3. Which makes my entire side of my big triangle 18 root 3. Okay, so let's remind ourselves what the area formula is. The area is the number of sides, because that's the number of little triangles we can make, like 1, 2, 3, you see them? Times 1/2 times the apothem times the side lengths, which remember are the height and base of my triangles. And we can start filling stuff in. N is 3. A is 9. S is 18 root 3. So I'm just going to plug in all of the stuff I found. Area equals 3 times 1/2 times the apothem, which is 9, times 18 root 3. Now these are all multiplications, so I can perform them in any order I choose. And I am going to just multiply all of these scalars together with my calculator. So 3 times 0.5 times 9 times 8. I'm getting 108 and then the root 3. So my area equals 108 root 3 units squared, and it says to give a rounded answer. So I'm going to multiply that by root 3. Oops, I messed up. 108 root 3, and I'm getting 187.06 units squared. That's it. Okay, so if I can use my little baby triangle and find out all of this information, I can just plug in my N, A, and S into the formula and grind it out. Let's try another one. So a reminder of the formula, it is that the area equals the number of sides times 1/2 times the apothem times the side length. Okay, so all we know right now is the side length. We don't know, we do know N. N is 3. 1, 2, 3. We don't know the A. We do know the side length is 10. So we have to find the A. All right, let's start by drawing some pictures. So draw in the center of your triangle and connect your vertices to the center to make your 3 baby triangles. Okay, now I'm going to draw in my apothem, which chops my side into 2 congruent segments. So if the whole thing, let me not do red because I did red for apothem. I'll do blue for the sides. These little segments are congruent and the whole thing is 10. These are each 5. Okay, now I need some information about my angles. The apothem is perpendicular to the side. Now I need information about the angles. It's going to take me 360 degrees to rotate around the entire total of the central angles. Okay, so I'm going to start with my 360 degrees and I'm going to divide by the 3 central angles that this figure has. Oops. So 360 degrees divided by my 1, 2, 3 central angles. That gives me 120 degrees. So this is 120 degrees. Okay, my apothem is going to chop each of those 120 degree angles in half. So this is going to be a 60 degree angle, giving me a 30, 60, 90 right triangle where this is my 30 degree angle. Now if I draw this off to the side, I know that this is 5. This is my 60. This is my 30. To go from my 5 to the short side, I have to divide by root 3. So 5 divided by root 3. I have to rationalize multiplying top and bottom by root 3. And I get 5 root 3 over 3, which is my apothem. 5 root 3 over 3. He's kind of nasty, but that's what he is. Okay, now I have everything else I need. I don't need to find out any more stuff. I can just plug my stuff into the formula. Okay, here goes nothing. Area equals the number of sides, which is 3, times 1/2 my apothem, 5 root 3 over 3, times my side length, which is 10. Okay. Don't make yourself crazy putting this in your calculator. If you can, look for little tricks. Do you see that I have a 3 in the denominator here and a 3 in the numerator here? Those bad boys cancel. Okay, now it's easy to put in 0.5 times 5 times 10, and you don't have to worry about dividing by 3 anymore. So 0.5 times 5 times 10. I'm getting 25 root 3 for my area. Okay, now I need to know what that is as a decimal. It is 43.30 units squared. So I just put that in my calculator and I round to the nearest hundredths place. Excuse me. All right, let's do another one. That one was so much fun. Okay, guys, this time we actually do have a hexagon. Let's remind ourselves what the formula is. Area equals the number of sides. Oh, hold on, my board's being dumb. Ooh. Okay, sorry. Okay, it's the number of sides times 1/2 times the apothem times the side length. So let's look at what we've got. We know the apothem. Oh, we know the number of sides is 6. We know the apothem is 4√3. We just need to find the side length. So the trick we're going to use is that we are going to find this little length, and then we'll multiply it by 2 to find the side length, because those little bad boys are congruent. All right, here we go. Let's connect our vertices to our center. Let me clean up this picture a little bit. I don't like how this looks. It's all muddy. I know that's 4√3, but it's kind of messing up my picture. I'm just going to rewrite it. So, not pink. Let's do blue. This guy we were given is 4√3. Okay, that looks better. So what we need is some information about our angles. Remember that if we rotate all the way around the central angle, the center of the figure, it's going to be 360 degrees. And I have 6 sides, so I'm going to take my 360, and instead of dividing by 3, I'm going to divide by 6 sides this time. And that's going to give me 60 degrees for each central angle. So each angle like this is 60 degrees. So that means that this little baby angle right there is 30. And this one is 60. Okay, now I have a 30, 60, 90 right triangle again. Yes. So to go, let me redraw this picture. So here I have a side that is 4√3. I have a 30-degree angle and a 60-degree angle. So to go from my long leg to my short leg, I have to divide by √3. That makes my short leg 4. So this little guy is 4, and so is his little twin, his congruent little segment over there. And together they make a side length of 8. Okay, now I'm ready to plug everything into my formula and crank it out. So area equals n6 times 1/2 times my apothem, which is 4√3, times my side length 8. So I'm just going to multiply all of the coefficients and scalars together. So 6 times 0.5 times 4 times 8. It gives me 96 as my coefficient for √3. A equals 96√3. And now I'm going to write it as a decimal. I'm getting 166.28 units squared, units squared. Okay, we're going to do one more. If you already understand what we're doing and don't need another example, you can start your practice. If you want to watch the last one, you can watch the last one. I'm going to do it for you. Okay, here goes nothing. It's going to be the same thing. They're just giving us a different piece of information. But I mean, how different can it be, really? Okay, let's start with the formula. We know that the area equals the number of sides times 1/2 times the apothem times the side length. So we need the A, just kidding. We'll start with the N and the A and the S. And this time they didn't give us any of that, which is irritating. All right, so we can find it though. So we're going to draw in a little apothem. Okay. And notice that we have a hexagon. Oh, we have N. N is 6. Okay. So we have N, we need A, and then we also need the side length S, which is going to be double whatever this is because these two are congruent. I'm going to zoom in a little bit. Whoa, too far, too far. Okay. So I have 360 degrees all the way around my center, and I'm chopping that into 1, 2, 3, 4, 5, 6 congruent baby triangles. So 360 divided by 6, that gives me 60 degrees for my central angle. So if I want to draw another one up here to show you what I'm talking about, this is 60. Okay, if that is 60, then this guy is 30, and his buddy down here is 60. So I have a 30, 60, 90 right triangle. I know that my hypotenuse right there is 12. Here's my 30. Here's my 60. Okay, so to go from my 12 to my short side, my hypotenuse to my short side, I have to divide by 2. Which makes my little short side 6. And this guy's 6. So my total side length is 12. Okay, now that I have my short side, I can find my apothem. Going from my short side to my height, my long leg here, my apothem, I have to multiply by root 3. So this should be 6 root 3 for my apothem right here. Okay, now we're going to plug everything in. Area equals 6 times 1/2 times my apothem, 6 root 3 times my side length, 12. I'm going to multiply all of my scalars and coefficients together. So 6 times 0.5 times 6 times 12 gives me 216 root 3 units squared. Putting it in to find the decimal and get 374.12 units squared. That's all she wrote.